the problem which you have to solve it. Very easy. Just for the sake of testing you, we have taken this numerical. How many nodes you are saying? 3 nodes. One is this much, another is this much, and another is this common node. Is it clear? What is the second step? Make common node as a ground node. Is it clear? 0 voltage. Assign the other 2 nodes as a unknown voltage V1 and V2. Clear? Now apply KCL at each node. So first we will apply KCL at V1. What is there? We have already done this numerical or? No. Okay. So what is there? Now already a current source is there moving inwardly. Therefore minus 4 into 10 raised to power minus 3 plus V1 upon 6 into 10 raised to power minus 3 kilo will become milli. What else? Plus V1 minus V2 upon 12 into 10 raised to power minus 3. Any other source? Any other branch? No. Equal to 0. Clear? Which can be further simplified as how much? V1 by 6 plus V1 by 12 minus V2 by 12 is equal to 4. Okay? So how much it will become? I think so 3V1 minus V2 is equal to 48. Equation number 1. Clear? What else about the second? Now write down the KCL at the node V2. Is it clear? What is there? Again, you have to keep in mind that the node which is under consideration, its potential will be assumed to be highest or maximum. So V2 by 6 into 10 raised to power minus 3. What else? V2 minus V1 upon 12 into 10 raised to power minus 3. What else? Now this is the current source which is flowing outwardly. Therefore it will be taken as positive. 2 into 10 raised to power minus 3 equal to 0. Rearrange it. What you will get? Yes, any problem? Current is going outwardly now from this node. No, that we are not concerned with this. Okay, mind it, don't go through the arrow direction. Okay, he is asking current in this direction, then we will change it. You need not have to worry. First of all, find out V1 and V2. Is it clear? So, or you need not have to worry about, because this is unknown current. Okay, so don't take its direction to take it into account into the nodal analysis. Is it clear? I will tell you how. So now rearrange it. What you will get? V1 3V. What about V1? V1 is minus V1 plus 3V2 is equal to minus equation number 2. Do you agree? What now? Solve this equation, 2 unknowns and 2 equations. How much V1? 15 volt. And what about V2? Minus 3 volt. Okay. Now please concentrate on the, yes, please concentrate. We have got these 2 volt. Everybody has got this? Okay. Now I have to find out this current. Okay. This current, the direction is this word, which my question state that V1 is higher than V2. So how much current I will be there? V1 minus V2 upon 12 into 10 raised to the power this minus 3. Do you agree? Do you agree or not? Okay, so what is V1? 15 minus 3 means plus 3 upon 12 into 10 raised to the power minus 3, which on solving comes out to be 18 by 12, which comes out to be 3 by 2, that is 1.5 milliampere. Now you have raised one question. Suppose in the question I would have given find out this current this direction, then up to this same. Okay, but now this current direction the question is indicating, it is assuming that this is higher and this is lower. So current in this direction will be V2 minus V1 upon 12 kilo. Okay, so what I will write down? Minus 3 minus 15 volt, that is minus 18 divided by 12, which will come out to be minus 1.5 milliampere. Do you agree or not? You need not have to take into the direction of the unknown currents during solving, but when you present the final answer, look towards in which direction the examiner is asking the current. Clear or not? Okay. Now, one more important thing. We have discussed Cramer's rule. We have discussed, na? So Cramer's rule is very important when there are more than two unknowns. If two unknowns are there, we can easily solve using the simultaneous equation. Is that clear? Any problem up to this so far? No? Okay. Let's move to some more numericals. So, I think so. I will give you the assignment rather than wasting time on the doing numericals. We will now focus on the circuit containing dependent sources also. So far, you have solved all the numericals which contains independent sources, either in current form or in voltage form. But now, we will encounter some problems which will have dependent sources also, in addition to the independent sources. Now, how to solve such type of problems? Mind it, first of all, how to identify whether it is a dependent source or independent? By shape, symbol. Is it clear? Which is used to be a diamond shaped. Okay. Now what happens? You have to somehow eliminate the dependent quantity. While solving the equation, okay, you have to eliminate the dependent quantity. Say for example, in this circuit, had this been the dependent source, let's say had it been current source like this. So, and suppose I have written twice I naught here, and let this be I naught this current. Clear? Okay, so the remaining step will remain as it is. What are that steps? Identify number of nodes, then assume one of the node as a ground node and assign the other node as a unknown variables V1, V2, V3. Write down the KCL at each unknown voltage node. Is it clear? Now, after you write down all the equations at each node, assuming that node voltage to be maximum. Is it clear? This all remains same. Now, after writing all the equation, there will come this term also. For example, in writing this equation here, instead of 2 milliampere, now it will come how much? Here it will come plus twice I naught. Is it clear? So, but my unknowns are which one? Real unknowns, V1 and V2. This is creating a problem. So, my whole effort will be there to eliminate I naught. To eliminate I naught means to express this I naught in terms of V1 or V2 or combination of both. For example, wherever I naught will be there, I will place what? V2 minus V1 upon 12 into 10 raised to power minus 3. Do you agree or not? This concept is clear. Means we have to take into account the unknown, the dependent source voltage or current as it is, as they are independent. But the dependent quantity has to be eliminated from the equation, that is, it has to be expressed in terms of the unknown voltages or current. The same is true for the mesh analysis also. Clear or not? In node analysis, unknown things are what? Our node. What are the unknown things in node analysis? What are the unknown things, Zahid? What are the unknown things in our node analysis? That is the node voltages, V1, V2, V3 up to Vn. Is it clear? So, we have to express the dependent quantities, maybe I naught, maybe V naught, in terms of unknown voltages, V1, V2, V3, etc. Is it clear? so that while solving the equation that unknown does not come into picture. Clear? Very simple. So let us take one numerical to have a better understanding of this concept. So I am writing down, I am just drawing the picture. Draw with me the corresponding circuit diagram. Okay, so find out the current through 6 kilo ohm using nodal analysis. So are you seeing any dependent quantity here? Dependent source? Are you seeing any dependent source? Yes, the diamond shape is the dependent current source. How will you name it? Complete name of this source? Current dependent current source. Is it clear? The arrow is indicating that current is flowing downward. Is it clear? So one dependent source is there and one independent source is also there. The same procedure. First of all, identify number of nodes. How many? 3. Do you agree? Okay, 3 nodes are there. Okay. What is next step? Make one of the node as a ground node or earth node. So its potential is 0. What else? We are left with these two. Let it be V1 and let it be V2. Clear? So first of all, we'll write down the corresponding KCL, Kirchhoff current law at equation number at node number 1, that is V1. So how much you will get? Now this is being a current source. Okay. First of all, we have to treat as an independent source only. Just an independent source. What we have done? We have, if it is a current source, we have taken the same value. What is the value of this? Twice I0. Twice I0. So I will write down, it is flowing outwardly, therefore it will be twice I0. What else? Plus V1 upon 12 into 10 raised to power minus 3. What else? Plus V1 minus V2 upon 6 into 10 raised to power minus 3 equal to 0. Do you agree? Everyone agrees? Okay, so now what else? Let it be equation 1. What else? Write down the voltage equation at KCL equation at node 2. So what is there? V2 minus V1 upon 3 into 10 raised V2 upon 6 into 10 raised to power minus 3 plus V2 upon 3 into 10 raised to power minus 3, and this is being a independent source having value 2 milliampere flowing inwards, therefore it will be minus 2 into 10 raised to power minus 3 equal to 0. So I think so there is no problem in equation number 2. Okay, so you can further rearrange it by eliminating 10 raised to power minus 3. So what you will get? Minus V1 plus 3V2 equal to 12. This is, let's say, equation number 3. Now who is creating problem? I0. That is equation number 1. What is, who is creating problem? I0. You have to eliminate I0. As I have already told you, try to express this I0 in terms of V1 or V2 or combination of both. So let's look towards this. What is I0? V2 upon 3 into 10 raised to power minus 3. So I naught is equal to V2 upon 3 into 10 raised to power minus 3. Do you agree? Do you agree or not? Okay, so now substituting the value of, let this equation be 4, substituting equation number 4 in equation number 1, what I will get? That is in equation number 1, wherever I naught is there, I will place what? Where I naught is there, what I will do? I will replace I naught by V2 by 3 into 10 raised to power minus 3. So here I am replacing I naught by how much? V2 by 3 into 10 raised to power minus 3. So just give me the simplification of this. How much you will get? 12 will be the LCM. So 8 plus 2. It is, I think so, 10 V1. We will get 10 V1 or not? Oh, you are so weak in mathematics, not replying me. It is very clear. I will take 12 as LCM, 4 to the 8, 8 plus, oh, it is V2, oh sorry, it is V2. It is V1 and here is 2 V1. So I will get, I think so, 3 V1. Yes, sir. Do you agree? Okay, 3 V1. What about V2? 6? 6 V2. Okay, 6 V2. And what about the constant value? 0. Okay, so this is equation number 5. Now I have to solve these two equations, equation number 3 and equation number 5. Okay, so how much I will get? How much I will get? I think so, 36 by 15. V2 comes out to be 36 by 15. Or what else? Yes? Yes, sir. 30, please, one more thing important. He has spoke 2.5. Don't try to put your answers in decimal. Put the answers in decimal only in the last result. But in between, always keep it in fraction form. Because what happens certain times when the things are not completely divisible, okay, you may approximate the result. Is it not? For example, you just say it is coming 33 by 4. Suppose it is 33 by 7 it is coming, suppose. Okay. So when you will divide it through calculator, okay, what you will find that it will comes out to be something 4.369 like this. Okay. So you will take only 2 digits. Is it not? So you are excluding or you are removing the remaining digits. Okay. So this may give you the at last erroneous result. So it is better, it is advisable, always keep your answer in fraction form. Only at the last point when you are finally submitting the result, convert it into decimal form. So it is better to give in fraction form. So fraction 36 by 15, which can be further simplified. It comes out to be how much? 12 by 5 volt. Mind it, don't try to forget the unit. Okay, what about V1? Huh? What about the V1? Minus 24 by 34. 24 by 5 volt. Everybody agrees? Everybody is getting this much result? Okay, now what I have asked you to find out the current through. Current through, what was the question? Current through 6 kilo ohm resistor. Okay, so the direction of the current has been shown this much. Okay, so is it assuming V1 is higher than V2? So what will be the current I? V1 minus V2 upon 6 into 10 raised to power minus 3. So just substitute all those value. What you will get? Minus 24 by 5 minus 12 by 5 divided by 6 into 10 raised to power minus 3. Solve this. How much you are getting? Minus 24 minus 12, I think so, minus 36 by 5, and 36 cancels in the table of 6. So it is minus 6 by 5 milliampere. Am I correct? Minus 6 by 5 milliampere, which you can write down as minus 1.2 milliampere. So this is your final answer. The minus is indicating that whosoever has framed the question, he has given the wrong direction. Actually the current is not flowing like this, but the current is flowing like this. Means this node is at higher potential in comparison to this node. You got my point? But if the examiner is asking, it is giving particular direction in this way, then you have to represent in this way. That answer is minus 1.2 milliampere. If nothing is being said, you have been directly asked in the question, find out the current through the 6 kilo ohm resistor, then it depends upon you. Always give the positive result. V2 is higher, therefore V2 minus V1 upon 6 kilo ohm. Is there any problem so far? Okay, so you came to know about the how to solve the dependent source problem. Is there any problem in this? Okay, if there any problem, then I should stop there, and otherwise I will move to the next question. Should I move forward? Okay. Is there any person who are not understanding? Yes, you two new people. Are you following my language? Are you understanding my language? I don't know the Dogri. I think the Kashmir language is Dogri or? You are familiar with the Hindi? No problem. Okay, or I should speak Urdu? I know Urdu also. Urdu? You are okay. Okay, fine, no problem. So we have the, I think so, 2 persons from Kashmir. We welcome you. So let's move to the next question. Now there can be, it is not that always there will be a current source. There can be a dependent voltage source. So let us take an example containing a dependent voltage source. Okay, so you have to find out the I naught. You have to find out the I naught with what is left. I think so it is 1 kilo ohm. एक क्वेश्चन दिया गया है जिसमें आपकी एक डिपेंडेंट किस टाइप का सोर्स है, current dependent voltage source. Okay, the positive and negative is showing it is a voltage source. Diamond shape is showing it is a dependent source. Okay, और ये 2k ix ये क्या शो कर रहा है कि किस प्रकार का सोर्स है, ये current dependent voltage source. It is clear? Okay, now mind it, this 2k is not constant. This k representing kilo, just as this. Clear? Don't get confused. What is unknown here? Ix. Where is Ix? This is Ix, and we have to find out I naught. Is it clear? So I naught you have to find out. Okay, so again using nodal analysis, very simple. How many nodes? How many nodes? 3. Okay, so this is one node, this is second node, and this is your third node. Make the common node or the third node as an reference node, the ground node. Okay, its potential is 0. Okay, so we are left with two nodes, V1 and V2. Mark it as V1 and mark it as a V2. So let us start with KCL at node 1, V1, that is. Okay, so how much it is, baby? Now mind it, this is a voltage source, dependent voltage source, no doubt. So again, while writing down the equation, you have to treat it same as if it is an independent source. आपको उसी तरह इसके साथ बिहेवियर करना है, कोई भेदभाव नहीं करना है कि नहीं तू अलग जाति का. Is it clear? इसके साथ कोई ग्रुपिज्म का गेम नहीं खेलना है. ये एक ही ग्रुप से वोल्टेज सोर्स, तो जैसा आपने वोल्टेज सोर्स के साथ ट्रीटमेंट किया था पहले जब वो इंडिपेंडेंट था, तो वैसे के वैसे इसके साथ बिहेवियर करना है जब ये डिपेंडेंट है. बात समझ में आई? सो लेट अस स्टार्ट. हाउ मच? यस, anybody more? Yes, anybody more? She is saying that KCL is not applicable to it. Is she correct? Is she correct? One thing is clear. What is the potential of this? 0. Okay. What is the potential of this? Or I can also say 2k Ix. Do you agree or not? So I got one equation. V1 is equal to 2k Ix. Clear or not? Is it clear? Because there is no resistance is there, therefore I can't find out what is the current. But I know that this V1 will become equal to 2k Ix. This is clear or not? Okay, that is what inference I am getting from node 1. Clear? Now what about the node 2? This is node 2. So what I will write down here? V2 minus V1 upon 2 into 10 raised to power minus 3, first term. This is a current source flowing inwards, so minus 2 into 10 raised to power minus 3, whatever, minus 4 into 10 raised to power minus 3, then what else? Plus V2 upon 1 into 10 raised to power minus 3. Do you agree? Equal to 0. Rearrange it, what you will get? I think so, minus V1 and plus 3 V2 is equal to 8. Am I correct? Yes, sir. Let's say this be question number 2. Now, we have two equations but 3 unknowns. We have 2 equations and 3 unknowns. Who is creating problem? Ix. Okay, so what is Ix? This is the dependent current. And what is Ix from in terms of V2? What is Ix? What is Ix? V2 upon 1 into 10 raised to power minus 3. Do you agree or not? Okay, so just substitute this value here. What you will get? V1 comes out to be 2. K means kilo. That is 10 raised to power 3. Ix is how much? V2 into 10 raised to power minus 3. So this is cancelled. So V1 comes out to be how much? Twice V2. This is again equation number. This is third. This is equation number 4. So solve equation number 4 and equation number 2. How much you will get the result in terms of V1 and V2. This is clear or not? समीकरण 2 और 4 को सॉल्व कीजिए, किसके लिए? हल कीजिए, किसके लिए? डिफरेंट टाइप्स ऑफ स्टोरीज, इज इट नॉट? So let us move to some more numerical, or you are bored with this? Bored? More? Okay. There used to be a slogan for the Pepsi, Dil Mange More, and the same is true for the circuit theory. I wonder, mathematically the Pepsi is equivalent to circuit theory. And numerical, mind it, anything left? You have to find out the current I naught using nodal analysis. Okay. What is different? How this question is different from the other question? What difference you are finding? No doubt the circuit configuration is different, no doubt. This is the first difference. What else? Now this time you don't have a current source, but you have no doubt you have a dependent source, but you have which type of this? Voltage dependent voltage source, or another voltage controlled voltage dependent source. Is it clear or not? So how to solve it? Again the same procedure. Identify number of nodes. How many nodes you are seeing? Yes? 4, sure? Can we start? I think so. You will tell this as one node. Do you agree? What else? This as a second node. What else? This as a third node. And this as a... Everybody agrees with this? Okay. I am running according to your decision only, okay? So, what second step? Make this as a ground node. Third step, make all the other node as a unknown voltage V1, V2 and V3. Clear? This is clear or not? What is the next step? Write down the KCL at each. Let's start with the V1. So what happens at V1? It is V1 upon 2, 12 into 10 raised to power minus 3 plus, yes, what I will write down here? V1 V1 anybody more? Yes, this question was intentionally being taken, okay, in order to give you a concept of so-called super node, a very important concept. Is it clear? Concept of super node. So far you have learnt about the node. You have learnt about the node. But what is the super node? Means something which is higher than the node. That's what you inference you can got from the word itself. Now what does this mean actually? There will be a super mesh will be also their word. Okay, just as super node is in our nodal analysis, we have a super mesh in our mesh analysis. What is the super node concept? Yes, what conclusion you are getting from this question? What can be super node? Whenever there is a voltage source is present between two nodes, a single voltage source is present between two nodes, we have to apply the concept of the super node. The same is true for the, similar way it is true for the super mesh. Whenever there is a current source, single current source or ideal current source or dependent current source is there between the two meshes, then this mesh will be termed as an super mesh. Now what we do in this super node? Okay, so this node, this will be considered as an super node. We have combined two nodes. And named it as an super node. Okay, we have just combined it, and then we have just said that this surface you are seeing, okay, though it is a bulky, generally node means a dot, is it not? Okay, but node in fact is meaning junction, means junction. So we have combined these two junction and called it as an super node. Now how we will take into account this super node in analysis? जब हम न्यूमेरिकल सॉल्व करेंगे तब उस सुपर नोड का कंसेप्ट कैसे लेंगे? तो आप लिख लीजिए while encountering the super node, we combine the two nodes and write down a single equation for the super node, concerned super node. Okay, so in this numerical, how many nodes we are encountering? Basic mistake I have done that I have first of all taken a dependent source. I would have taken first of all an independent source, then would have explained, but no problem. What happens that we will combine these two nodes, is it clear, and make it as a single node. Single node does not mean that we are eliminating its voltage. This voltage will remain as it is it clear? So how it will change? Can anybody refer me? If I know the voltage of this, can I know the voltage of this? Okay. Do you agree? Okay, then why should I assign V2? Can I represent this V2 in terms of V1? Huh? Do you agree? How? If this is say V1, what will be the voltage of this one? See, very simple. What is this voltage? 2Vx. Is it clear? This is plus and this is minus. Plus is indicating this is at higher potential and this is at. Do you agree or not? Is it clear? So what I will get? V1 minus V2 is equal to twice Vx. Do you agree? Do you agree or not? Okay. So I can write down V2 as V1 minus twice Vx. Do you agree again this? So what the voltage of this will become? V1 minus twice Vx. Clear? It is clear or not? So you need not have to choose another unknown voltage is V2. And this type of question will arise whenever there is a super node is there. Okay, that is you have to express the other node voltage in terms of the nearby node voltages. Nearby node voltage is what? V1. Okay, just express this voltage in terms of this. And now what will happen? What you have to do? You have to write down a single node voltage equation. A single node voltage equations. How will you write down? Anybody can suggest me? What will be here? V1 upon 12 into 10 raised to power minus 3. What will be there? V1 minus 2Vx upon 6. Clear? What I will have? V1 minus twice Vx minus V3 upon 12. Now upon 12 into 10 raised to power minus 3. Clear or not? Okay, so this will become a single equation. Is there any problem so far? This type of problem or this type of node is called super node. Is it clear? And therefore we are left with only two unknowns, V1 and V3. Is it clear? And what about the second equation for V3? Very simple. V3 will equal to 6 volt. Or is it not? This is 0 volt. What is the voltage of V3? 6 volt. Clear or not? Oh, one more equation you have forgotten in writing down there first. V1 minus V3 upon 6 into 10 raised to power minus 3. Clear? So two equation, two unknowns. You can solve it or not. Okay. Today I am dropping here this topic. I will again take the same numerical tomorrow. Is it clear? Before taking this numerical, I will first of all take a circuit containing super node with only independent sources. Is it clear? You will identify through the concept which I have given, identify where super node is there, how to replace it, and then solve it, and then we will take this question. We will solve it. Is there any problem so far this? Anybody who hasn't understand the concept of super node? Super node will arise whenever there is a common voltage source, ideal voltage source between two nodes. Mind it, had there been a resistor is there, no super node concept. Resistor will allow you to flow the current. Is it clear? But this, had there been ideal voltage source, then the concept of the super node will arise, whether it is a dependent or independent. Clear? Is there any doubt, difficulty, कोई शक, कोई सवाल? Should we stop today? Okay, that's all for today.